Hello, I'm MC Toon. Flat earthers, they don't do math. Not really at all. A couple, maybe one or two of them, but they don't do math. So I saw this video, and this flat earther had a book with a bunch of formulas in it. And I'm like, is he going to do math? Well, let's watch and see what he does.
It is to confirm rockets push off air and Daniel Pratt's video about centrifugal force, and this book actually exists, is real for engineers or machinists.
That's right, he found the Machinery's Handbook, a book starting in 1914. He has the 13th edition from 1948. Now, it seems to him like this is a hard-to-come-by book, but if you were to just maybe go to Google and type in Machinery's Handbook PDF, you could find the 26th, 27th, 28th, 29th, 30th version for free, like I did. So I'm going to look at the 27th edition, which is from 2004, and I compared it to the version that he has on his video, and they're almost identical, especially on the part that he's going to look at here in just a second.
And the centrifugal formula is in here regarding flywheels. This is what when I said in my comment, which will put a lot of people off because the formula looks a bit complicated, you see.
Oh no, it looks a bit complicated. Does that mean you're not actually going to do some math? Why'd you even get this book out?
Let me get a nice close-up of that. Long focus.
Moonshiner? Dude, look at this. You're not supposed to acknowledge gravity. It's right there on the screen. You gotta pretend that doesn't exist. What are you doing?
There's your formula, okay? Looks frightening, but it ain't too bad. But the good part about this book, it does something for you see. It's got a table here. Hang on. All right. Right. Put that over there a bit. I'm getting a bit close to that. Anyway, right. This tells you this is table for centrifugal force. And you got, yes, your mass of the wheel is something, and the relative size and whatnot. You can look it straight up for engineers. Okay, if you're designing a machine, you have to have you're going to make sure your flywheel's strong enough, not made of loose soil.
All right, so he has this table. Now, he didn't seem to know what it was. He pointed to the column labeled N and said it was the mass. It's not the mass, it's something else. And then this other column that's C. He doesn't know what that means either. But here's what N means. It means number of revolutions per minute. And if you look at this table here that I have from the 27th edition, but it's the same as the 13th edition, the lowest value for N is 50. Now, did he calculate the revolutions per minute of the Earth's rotation? We'll see in a minute if he went to that trouble.
If I'm using this formula, because it's very important for making things such as chop saws, for instance. There's a chop saw. Let's get that speeding. see that. Yeah. Here it says 5,100 revs per minute, or 80 metres per second at the rim. Okay, 80 metres per second at the rim. 5,100 revs per minute. That's the maximum that can go.
Well, no big surprise. Moonshiner's not doing any math at all. But I'll do it for you. It's not that hard. If he were to Google centrifugal acceleration formula, he would find out that all you need to do is take the velocity squared and divide it by the radius. So here we go. The velocity is 80 meters per second. Squaring that, you get 6,400. And the radius is, later he shows us that the diameter is 11 inches. That means the radius is 5.5 inches. If you convert that to meters, because we want to do this in SI units, you get 0.1397 meters. So you divide 6,400 by 0.1397 and you get 45,812 meters per second squared. That's right. The centrifugal acceleration on that chop saw is 45,812 meters per second squared.
And I thought that was quite slow because I've been used to that's off a chop saw, okay? Well, here we got one. Off a, see that? That's off a angle grinder. You see? And we go. You can see that properly there. That's allowed to go 13,300 revs a minute at 80 meters a second.
All right, well, he's not doing the math again, so I'll do it for him. 80 meters per second is 6,000 squared is 6,400. The diameter of that smaller disc is 4.5 inches. The radius is 2.25 inches, which is 0.05715 meters. Right? So you take the velocity squared divided by the radius. The velocity squared is 6,400 divided by the radius, which is 0.05715 meters, and you get 111,986 meters per second squared. Centrifugal acceleration at the rim. That's more than twice the bigger blade. More than twice the bigger blade. That's the math. So let's see what he says.
No. Why couldn't the small one go faster than the big one? Because there's more centrifugal force on the big one. The bigger it is. I mean, it's a massive, isn't it? Right, let's get out of it. See the difference in the size of these? Right. Okay. See ya? That's 5,100 revs. That's 13,000. Nearly 3 times the difference. We're talking inches here, ain't we? Right? The big one is 11 inches across on the rim. Well, the diameter, I mean. 10 3/4, that is. It's been used a bit. And the little one is 4.5 inches. You see? It's all to do with the rim speed. Now that kind of 13,000 revs a minute. I think I've worked it out fast, and it's going about 20,000 or 30,000 revs a minute. It only amounts to about 300 miles an hour before the thing will blast itself to pieces.
Well, Moonshiner has made quite a blunder here. He said that the bigger one has more centrifugal acceleration, but didn't do any math to figure out if that was the case. He just said it is because he felt like it is. I don't know. When it's the opposite. If we were to look at these discs, you can see that the smaller one is much, much thicker. That's probably why it can handle more acceleration. So where is he going with this? Is he going to make another blunder? Well, let's find out.
4 inches. 300 mile an hour around there. Sorry, man. Woof. It'll just blow itself to pieces.
Well, yeah, it will blow itself apart. It's got 45,000 meters per second squared on the big one and 11,000 meters per second squared on the small one. That's a large centrifugal force.
So the Earth's supposed to be going at 1,000 mile an hour. We lose soil. No, that ain't going to work, is it? So this video is just to confirm what Daniel Pratt made a video about, and rockets push up here. The machinery handbook is there for engineers to do important calculations as far as centrifugal force is concerned.
What are you talking about here? We would lose dirt? You didn't do the math. You didn't do anything. You're going to confirm what? That something Daniel Pratt said and a guy named Rockets Push Off Air said, but you didn't actually do anything to confirm it. You referred to this handbook, but you never used it. Not once. You don't even need to. The formula's not that hard. So let me do the math for you again. The Earth's radius is 6,371,000 meters, right? The velocity of the Earth at the equator is 1,037 miles an hour, which is 463.5805 meters per second squared, right? So we're going to take the velocity squared, it'll be a big number, divided by the radius, another big number, right? So the velocity squared is going to be 214,907 meters squared per second squared. You divide that by 6,371,000 and you get 0.03373 meters per second squared. That's not a big centrifugal acceleration. Your example had 45,000 meters per second squared. The Earth is 0.03 meters per second squared. Moonshiner, that book is to do math with, and you didn't do it. It's in the book. You could use it. You could do the formula and find out for yourself that you're completely wrong, and so is Daniel Pratt, and so is goofball Rockets Push Off Air. So, sorry, you completely disproved everything, and you did show once again that flat earthers can't do math. Not even once.
You see, the bigger it is, it has to go slower. And it's calculated to the rev per minute.
Yeah, it's calculated by the revolutions per minute, which you also didn't calculate for some reason for the Earth. So let's do that for you real quick, just before we go. 1 revolution per day, divide by 24 hours, divide by 60 minutes, that gets 0.00069 revolutions per minute. You said we needed to use revolutions per minute. That's the revolutions per minute that the Earth spins. Now, your table from earlier that you did show has that column N, which is revolutions per minute. The lowest number on that table was 50 revolutions per minute. You can't use that table to calculate the rotation of the Earth because it's 0.00096. It's too small. So you just get to use the formula. I'm sorry that the formula hurts you so much. It's too bad. Whatever. Well, anyway, he rambles on for a bit, and it's pretty useless because he already disproved himself. So thank you very much to my members and patrons and everybody that supports my videos and everything else I do. If you like this video, make sure you like it. If you are new to this channel, make sure you click subscribe and the bell. If you are Moonshiner, you'll probably just click the thumbs down. That's fine. And maybe you want to tell me all about it in the comments and correct my math if you think I'm wrong. I'm up for that. Any flat earthers? Yeah, correct my math. That's funny. All right. Thanks a lot. We'll see you next time. Bye.